Students, in this video we'll be having a look at into the basic terminologies that anybody should be familiar with while doing circuit transient analysis. So these are the contents that we are going to have a look at in this video. So given a circuit, broadly it could be classified into two kinds. That is, one is resistive circuits which contain only resistances in it, whereas the other kind would be circuit that is containing energy storing elements like inductor and capacitor. Transients don't occur when you have only resistances in the circuit. So we need not talk about a transient analysis in a purely resistive circuit, whereas transients occur in a circuit where energy storing elements are connected. This is because the voltage or current across resistors change immediately when the energy sources are connected to it or when the energy sources are removed from it. Whereas in case of inductor and capacitor, when energy sources are connected to it as well as when the energy sources are disconnected from it, it takes some time for the inductors and capacitors to respond. That is, the voltage or the current across the inductor or the capacitor will take some time to reach its steady state value. So because of the time taken by these energy storing elements to reach its steady state value, the transients occur. So let me consider a switch like this to be connected to a electric circuit. So this switch will be now capable of closing or opening so that it connects either the source to the circuit or disconnects the source from the circuit. So let us define uh, time t is equal to 0 as the moment where you're going to either close the switch or open the switch. So if time t is equal to 0 is the time when the switching activity is going to take place, either closing or opening, then time t is equal to 0 minus has to be considered as the moment just before the switching activity, and time is equal to 0 plus has to be considered as time after the switching activity. That is the moment after the switching activity. The switching activity either can be closing or opening of the switch. So in case of resistors, the current before the switching activity is not equal to current after the switching activity. Likewise, for voltage also, the voltage before the switching activity is not equal to voltage after the switching activity. V of 0 minus is not equal to V of 0 plus, which means resistors respond immediately to the energy sources either connected to the resistor or disconnected from the circuit. Whereas in case of inductor, the current before switching is equal to current after the moment of switching, which means that the inductors does not allow sudden change in the current. In case of capacitor, the voltage across the capacitor, the time before the switching is equal to voltage across the capacitor the moment after switching, which means that capacitor does not allow sudden change in voltage. So inductors does not allow sudden change in current because of the switching activity. The switching activity can be both ways. That is, either the energy sources can be connected to the circuit or the energy sources can be disconnected from the circuit. Both cases, inductors does not allow sudden change in current, and the capacitors does not allow sudden change in voltage. And this is how RLC components behave for switching activity. So coming to transient period, the time required by the network to change from one steady state to another steady state. This time period is what is called as a transient period, and the values of current and voltage during this transient period is what is called as a transient response. So whenever there is going to be a switching activity in the circuit and your circuit is going to contain energy storing elements, then we are keen on analyzing the what are the values of currents and voltages during this transient period. So such analysis is what is called as transient analysis. So we are keen on looking into what is the value of current and voltage during this transient period. So that analysis is called as transient analysis. So in next videos we will be dealing with how to do transient analysis for various kinds of circuits. Coming to the definition of a free and a forced response. So free response is nothing but, for example, if you have got a network, and in this network, if there is no input, so you are not going to apply any input here, okay, no input, but still there is a response because of the earlier stored energy in the circuit elements in the network. If the elements in the network earlier it is energized by some sources, then even when you don't have any input, you will get a response. So such kind of responses are called as free response or natural response. Free response or natural response. So this is because of initially stored energy in the circuit. Of course, this free response will die out quickly because it is only because of the initially stored energy. This initially stored energy would decay to zero. So this response, free response, would die to, or it will cancel, or it will decay to zero as quick as possible. So forced response is nothing but take a network and assume that there is no initially stored energy in the network, and when you're going to give input, the response that is obtained because of this input alone, uh, and we have assumed that there is no initial energy stored in this network. So in that case, the response is because of only the input given. Such responses are called as forced response. Such responses are called as forced response. So obviously, for a network which is going to contain both the initial energy as well as it is going to be supplied with input, then your will be sum of output will be or response will be sum of free response, because you have initially stored energy in this network. So it will be a sum of free response plus forced response, because you have a input here. Free response is because of the initially stored energy in this network. Forced response is because of the input supplied. So finally, the output of this network will be summation of free response plus forced response. Coming to this complementary function and particular solution, so if you are going to write a differential equation which is going to govern a particular network or circuit, then after solving the differential equation you get the response, isn't it? So you get the response which will be sum of complementary function plus particular solution. This we have studied in solution of differential equations. Mathematically, this complementary function is nothing but the free response of any network, and particular solution accounts for this forced response. And students can recall that while finding the solution of differential equations, this part of the solution we would have got by forcing the input to be zero, and this part, particular solution, would be got by giving the input. So both are, this is mathematically written now, that is the output is equal to complementary function plus particular solution, or otherwise it can be called as free response plus forced response. We can also note that in this particular network, when time t tends to infinity, what will happen? When time t tends to infinity, this free response dies out, and when time t tends to infinity, we have only the forced response existing. So this response will be that time called as steady state response. So your uh, output when time tends to infinity will be called as steady state response. So these are some of the basics for transient analysis. In the next video, we will be looking at transient analysis of different types of circuits.